Before we begin the actual repair of the machine, I'd like to draw your attention to one aspect of this particular machine. It has two buttons on here, one for each side to control, to turn on the brewing, and then alongside it has a stop button on either side to stop the brewing process partway through. What would be the point of having something like that? If the machine is operating properly, why would you want to stop it partway through? On the other hand, if the machine is malfunctioning and it is running over the top or about to run over the top, I see why you'd have a stop switch. Because you want to stop it from running coffee all over your counter. Today, when we get inside this machine and do the repair, we're going to solve the problem. We won't need a stop switch anymore. Now I've turned the machine on its side, on its back actually, in order that we can solve the problem of these extra switches that are here. So I'm just going to find the right tools to do it. You have to be very careful. It's on top of the switch directly here. This is not the brew switch, but the stop switch. And we'll just remove that switch from here. There we go. Other one. There. Okay. Now, having removed those two switches will make it a lot less confusing for the operator. They'll hit the brew switch to make a brew of coffee. Now, we'll move on to the timers. Okay, we have the cover off here now, and we're able to see the inside of the machine. And briefly, this is how it works. There's a boiler here. Fresh water in there. It's heated up to almost 200 degrees. That water in turn is fed through these two valves, through spray heads and into the coffee receptacles themselves. That operation is controlled, one on each side, by these printed circuit panels. They also contain the timers that control the volume of coffee produced. That's where our problem is, and that's where we're going to have to spend a little time. Before we do that though, let's just consider all the rest of the componentry that's in here. It's here for various reasons. Most of it's fairly important. Some of it is in there, for the engineers like to make it look complicated, but we pretty well know our way around. We'll get it fixed up without worrying about that. Alright, so we've taken the coffee brewer machine and we've set it onto the floor, so it's going to be more easy to actually perform the service work on it. Now the first thing we'll draw attention to here is a classic example of what I mentioned before, where the engineers have simply put a wire on that just loops from here to here. It doesn't do anything. There's no need to have it there, it's just confusing in the machine. This side of the brewing machine is the side that tended to overfill regularly. Now, we've removed the timer switch in order that it will stay exactly where it is. Now what we're going to do is we're going to govern that flow in a far more reliable manner by simply adjusting the flow to the spray head. I have the tool for that. Here we go. This is sometimes used for clamping wood and so on as well. But here, this is one that's designed for the coffee machine. I will gradually apply more pressure to that tube until the flow through there is exactly such that we have a full pot of coffee each time. That takes care of this side of the brewer. It will now brew a coffee each time exactly or correctly. Now we'll spin the machine around and we can see the timer on the other side. Now this one routinely was underfilling the pot. That's a little more tricky to repair in some ways. First of all, these wires, it's the same as those ones there, but they're in the way of the timer. So you can bend them out of the way a little bit there. It's okay. Really, it's the white wires here, those don't really actually do anything. It's the colored wires that carry the power, and they're the ones that you have to be a little more careful. Now the first thing here is this timer knob. We want to make sure that when it is adjusted, that it's adjusted correctly. Now, you can turn it a little bit and you think, okay, that's all not too bad. But inside there's corrosion of some kind. There's a small amount of corrosion that is causing the contacts not to open when they should. Now, the best way to do this, there's two ways. One I'll try right now. Tools. And that is, you put your wrench on there and you give it some turns. Just back and forth like that. Okay, just to see if it loosens it up a little. Now, okay, yeah, see, I can see I fixed it there a bit, but I'll bet you it's still not quite right. What's going to happen is that sometimes it'll be right, but sometimes it's not, because I can still feel there's a little bit, there's a little bit of corrosion in there. We have to deal with that. That's going to require turning the machine one more time, a little farther around like this, up against there. There we go. And now we're going to have to deal with that corrosion. We're going to have to get that corrosion to move out of the control, what's called a potentiometer. We're going to have to remove that indirectly. If I was to try to remove it directly by applying force to the printed circuit board, I would ruin the circuit board. We can't do that. So we're going to have to deal with it indirectly. Okay. I love repairing equipment. Didn't seem to do it. Did you hear it? I'm not sure if we've got that yet. No, there's still a little rust in there, I can tell. Okay. Oh, there it goes. There it goes. We just heard it. I think it's fixed. I think it's fixed. Excellent. Repairing equipment. Commercial equipment in particular. It's fantastic. So rewarding when you actually have it in its face.